Hello everyone, I welcome you all to the SANPoint OnStream YouTube channel where the success is guaranteed. In today's video, we are starting with the new subject, that is fluid mechanics, and this lecture will be helpful for all those who are preparing for civil engineering government exams like RWS, KRIDL, SSC-JE, or if you have plans for the higher studies by writing the exams like GATE and PGCET. So my name is Lakhanpal. Let's start the session. So these are the topics under the fluid mechanics which we need to study. So there are total 12 chapters which we are going to deal with. So first one is the introduction, which we will be completing in this lecture. Further we have to study about the basic fluid properties. Next is pressure and its measurement. Then comes the fluid statics, fluid kinematics and fluid dynamics. In statics the fluid is in rest, while in kinematics and dynamics the fluid is in motion. Then we have the laminar flow, vortex motion, dimensional analysis, pipe flow, boundary layer theory and concept of drag and lift. So various things we are going to learn from here, and with the help of that we are going to solve various numericals. So in each and every chapter we are going to solve various questions from different types of exam. We will be dealing with the questions from various government exam which have been asked previously, and that will help us in building our concept even more. So let's start with our introduction part today. So in this introduction part we are going to talk about some basic definitions which are generally helpful in interviews, and also they will help us in building the concept further. So let's start. So first such important definition is flow. So flow is basically the relative change of position of the particles with respect to time. Now here when we are talking about particles, we are referring to the fluid particles because the name of the subject is fluid mechanics. So fluid particles we are talking about, and their position is going to change with respect to the time, that is called as flow. So let's understand this with this diagram which is on the right hand side. Now in this figure we have been provided with the plate at the bottom over which the fluid is present. Now this fluid, for the time being I am considering it to be water. So water is placed over this plate. Now we have applied certain force F. So here you can see that a force F has been applied which is called as a shear force. Why shear force? Because it has been applied parallel to the surface. So the force which is parallel to the surface is generally called as the shear force, or it is called as the tangential force. Now due to the application of this force we are going to see what are the changes that can be seen in our fluid. So here we are considering the fluid particle or the water particle. So at time t equal to t naught, at time t equal to t naught, our fluid particle is present somewhere here. Now on the application of this force we are going to see that our particle will start moving in the forward direction. So here at some different time, that is time say equal to t1. So at time equal to t1 our particle has taken a new position and it is now present somewhere here. Further at some other different times, say t2, t3, t4 and so on, we are going to see that continuously the position of this particle, it is changing. So initially it was present here, then it is present here. Now further it is moving in the forward direction. So it is changing its position. So this kind of property where our particles are changing their position with respect to the time on the application of certain tangential force is called as flow. So flow is the relative change that we are going to observe in the particle with respect to the time. Next important definition is property of flow. Now why this flow we are able to see? So this property of flow is basically seen in the case of liquids and gases. That means this phenomena is not going to happen in the solids. Only in liquids and gases we are going to see this property. That means property of flow is a property of a fluid, and we have two types of fluid, which are liquids and gases. Now why this flow is happening? So here also same thing has been written, that this flow is happening due to the shear force or the tangential force. So under the action of shear force or the tangential force, we are seeing that continuously deformation is taking place. Deformation means that the position of the particles are changing. This is deformation that we are going to see on the application of the tangential force. And this continuous deformation is nothing, it is called as property of flow. But this thing is missing in solids. In solids, if we apply the force, then obviously there will be deformation, but that deformation is fixed. Up till certain amount only that deformation will be there. It will not be a continuous deformation. So this is the reason why liquids and gases are kept in a different category from the solids. So here it's written that liquids and gases, they are kept in a separate category which is called as fluid, and solids are kept in a different category. They do not possess the property of flow. So to understand it further, we have our next slide. So here we are saying what kind of deformation will be seen in fluids and what kind of deformation will be there in solids. So for fluids, we have already seen that the relative position of the particle is going to change with respect to the time. So here the deformation that is happening, that is changing with time. Here the initial deformation was only θ1 angle. Then further if I talk, the angle is getting increased. Say this is θ2. Further if I talk about, further the angle is increasing, that is a θ3. Further the angle is increasing, say angle is θ4. So continuous deformation we are going to observe. While in the case of solid, when we are applying the force F, which is again a tangential or the shear force, that means it is acting parallel to the surface. Now for a fixed value of F, we are going to see that the deformation, it won't be a continuous deformation. The magnitude of the deformation in this case will be a constant value. While in the case of the fluids, our deformation is continuous till the point this force F has been applied. And here this force F can have very small magnitude also. We have seen this practically also. We have seen that if we drop even a small leaf on the water surface, then also there is some kind of ripples which can be observed. That means a very small, infinitely small force is also responsible for continuous deformation of the fluids. While in the case of solids, the magnitude of the force should be significant, then only we can observe the deformation. Next point is, in case of fluids, we are more interested in knowing what is the rate of deformation. Rate of deformation means d theta upon dt. That means this angular deformation which is happening with respect to time we are considering, because we know that the particles are changing their position with respect to time. So at every time instant, this theta angle will be different. So here our shear stress, that is directly proportional to d theta by dt. Further also we are going to discuss this concept when we will be dealing with the Newton's law of viscosity. There also we will be discussing this part. But if I talk about the solids, in solids the shear stress is responsible for the deformation or the strain. So here we are only interested in the magnitude of that deformation. So here the tau is directly proportional to phi. So phi is basically here the shear strain. So here we are concerned with the magnitude of the deformation, while here we are interested in knowing what is the rate of deformation, because most of the properties in the fluid, they are going to be related with the rate of deformation rather than the deformation. But if I talk about the strength of materials, in strength of material we were interested in finding what is the value of the strain or the deformation which is occurring. The next definition is fluid. So fluid is any substance which can flow, or in other words we can say that it is any substance in which we are going to observe that the particles are changing their position with respect to the time. And fluid can be classified under two categories, as we know. One is liquid, the other is gas. Now what is the basic difference between liquid and gas? That we are going to see here. So if we talk about liquids, these are the fluids which are having a definite volume. So what is the meaning of this? Suppose I have a container, and here in this container I have filled say 1 liter of water. In this, the quantity or the volume is 1 liter. Now what I do, I take another container. The shape of that container is bit different. Suppose the container is like this. Shape of the container is like this. And what I am doing here is, I am pouring this 1 liter water in this container. So here the water will look something like this. The shape of the water will change, but the volume will still remain to be same, that is 1 liter. Again, if I take another container, suppose the shape of that is something like this. We are taking a pot, something like this, and now I am filling the 1 liter water in this. So the 1 liter water will look something like this. Same water I am pouring, suppose. So again the volume of water will be 1 liter. So what we can say from here is that liquids have definite volume. The volume does not change, only the shape of that fluid or the liquid can change. And this volume, it changes slightly on changing the temperature and pressure. Now suppose this 1 liter of water which was placed in the first container, it was say at temperature of 30 degrees Celsius. Now if we further increase the temperature, suppose if we take it to say 70 degrees Celsius. So due to the increase in the temperature, the volume will change, but that change will be very small. Same way, if we increase the pressure or if we decrease the pressure, then also there won't be much change in the volume of the liquid. So this is another property for liquid. First is they have definite volume. Second property is that their volume, it changes slightly on changing the temperature and the pressure. And this is the reason that for the practical purposes, we are going to consider that our liquids are incompressible. So here it is written that it is considered to be incompressible. Means the volume changes we are not going to consider for the practical purposes. We are going to say that the volume remains constant even if we change temperature or pressure. Although theoretically we know that there will be certain change in the volume, but that change is not significant. Now let's talk about the gases. So gases are basically compressible in nature. That means we are going to see that there are volume changes on change in the temperature and the pressure, and they also do not have a definite volume. Means if suppose we have a container something like this and we have filled the gas, so this gas is going to expand itself up till it takes the volume of the container. If we have suppose another container something like this and gas has been placed, so now this gas is going to take the volume of the spherical container. So it is going to expand and it will take the volume of the container. But this was not the case with the liquids. Liquids were having a definite volume. Whether we change the container, the volume remains same. But here, depending on the volume of the container, the volume of the gases also changes. Another property with respect to the fluid state is that they can resist only two type of forces. One is compressive force and the other is the shear force. They do not take care of the tensile forces. Like in the case of solids. In solids we can apply compressive force, we can apply tensile force, and we can apply shear force also. So some kind of resistance will be shown by the solid body when these kind of forces are applied. But we cannot apply the tensile force for the fluids, because if we apply the tensile force, no resistance will be offered from the fluid for the tensile force. So this point has been written over here, that the fluid state, it can resist only two types of forces, it cannot resist the tensile force. Now the next important definition is mechanics. So this term mechanics is basically originating from physics. So here we study about the forces and its effect on various kind of bodies. Now these bodies can either be solid, they can be fluid also. So suppose our body is a solid body and on that forces have been applied and we want to study what will be the effect of the force. So that kind of study comes under the strength of material. In strength of material, our body is a solid body over which we apply forces and then we calculate various parameters such as what is the stress, what is the strain, and various such parameters can be calculated. Similarly, if our body is a fluid body, then the study will be called as fluid mechanics. So here the study of forces and its effect will be seen on the fluids. Fluid can be a liquid or gas. Now when we do the analysis of the fluid, either our fluid can be in rest condition or it can be in the motion. So based on that, we have few more terms over here such as fluid statics. So in fluid statics, it is assumed that the fluid is in the rest condition. Next is fluid kinematics. Here our fluid is in motion, but another point we have to take care here is that the cause of that motion we are not concerned about it. That means certain force or pressure difference might have been responsible to cause this motion. But here when we deal with such fluids, we are only concerned about the motion. We are not concerned about the forces or the pressure difference which are responsible for creating that motion. While if we talk about the fluid dynamics, so in fluid dynamics, again the fluid is in motion, but here we also take into the consideration the cause of the motion. So whatever force or the pressure difference is responsible, that also come into the picture when we are dealing with the fluid dynamics. Now when we do the analysis of the fluid, that time we have two approaches. One is called as macroscopic, the other is called as microscopic approach. So we need to learn what is the difference between them, and also we should know which one we are going to adopt for our analysis. So let's consider an example over here. So I am considering a container, something like this. This is our container, and in this container say water is present. So in this container, say up till this level water is present. So now if we go to the microscopic level, so if I zoom this portion, this will look something like this. The water particles or molecules will be present, something like this. And clearly we can see that there is certain distance between these particles, which we generally call as intermolecular distance. Now if I go by the macroscopic approach, let's see what it says. It says that the distance between the consecutive particles, it can be considered as negligible. That means we are considering the intermolecular spaces or intermolecular distance between the particle, that is negligible. And under this condition, we call our fluid to be continuum. Continuum. Why? Because here we are considering that our fluid is continuously present. So that's why the name is called as continuum, because here the distribution of the mass is continuous. So same thing has been written over here, the continuous distribution of mass, which is called as continuum. While in the microscopic approach, here we do not neglect the interdistance between the particles. So here we know that certain distances between the particles were existing, and these distances we do not neglect in the microscopic approach. And here we cannot treat our fluid to be a continuum or the continuous matter. Now out of these two approaches, where we are considering the intermolecular distance and we are ignoring the intermolecular distance, which approach we have to adopt? So we go by the first approach, that is the macroscopic approach. Now this question can be asked, or it has been asked many times in the exam, that which approach do we adopt in the fluid mechanics. So we go by the macroscopic approach. Although it is not an accurate approach, but for the simplification purpose or for easy calculations, we are adopting this approach where we consider our fluid to be a continuous matter. So we are basically ignoring the spaces or the voids, we can say, which are present between the particles of the fluid, so that our analysis becomes easier. So we always go with the macroscopic approach where we are ignoring the intermolecular distances. So that's all in this first lecture, where we have understood various definitions like flow, the property of flow, what is fluid, what are the categories of fluid, like we have gases, we have liquids, what is the basic difference between them. We have talked about mechanics, we have dealt with fluid statics, fluid kinematics, fluid dynamics, and lastly we have talked about which approach is more suitable for doing the analysis of the fluid. Now in our next video we'll be dealing with our second chapter, that is the basic properties of the fluid. So if you want more content of this type, so do like, share and subscribe our YouTube channel.